Hey guys, good morning. Today is October 15th and it's about month 5 of my lawnmower project. Just wanted to do a quick video on where I am with it. Um, so this is my little setup here. I've got a little bit of hardware work done. One of my neighbors, he's got an awesome garage full of like metalworking equipment who helped me build this thing. David, if you're seeing this video, you're absolutely awesome and I love this thing. It's a very simple design. The idea being you would hang a lawnmower right in the middle here. It could be any kind of lawnmower. It could be, I mean, all it needs to be is a 21-inch base lawnmower, and you could literally hang it in the middle. So this frame takes the lawnmower for a ride, and rest everything is electronically controlled. So the lawnmower here is not the big deal. I think this frame that guides the lawnmower around is probably the most interesting thing here. Has a very simple differential drive motors on the back. So this one has front wheel casters. So there's no steering mechanism except through changing the power on these back wheels. The motors themselves have like high sensitivity encoders on, which provide speed information back to the processing system, and it's got like current draw and everything else that could be read from it. So I mean, if you notice, we don't have any suspensions on these systems, and lawns are not the most flat places ever, so all that, putting traction on the ground is going to be done electronically through algorithms and stuff. So the frame itself is really simple, not much to it. Here is where all the magic happens. This little box here, I call it the lunch box. It's got a whole bunch of sensors in. It's got the GPS on the top, and it's got the 2 Raspberry Pis. It's got motor controllers on the bottom, and the third one's supposed to have fallback and battery backup and so on. So I've kind of isolated where you have the sensitive electronics on top, have the high current like motor controllers on the second level, so it's kind of isolated, and then the third level will have all the backup systems together. The GPS here is a really high precision, almost close to a foot to a meter precision, which you probably need because you're in very small spaces for lawns. Right now this is hooked up to my ground control station here that I'm running on my laptop here, and there are 2 Raspberry Pis in there. Has 8 cores of power, and it's supposed to do different things. The sensors itself, there's like many of them, so there's inertial measurement units, you got compasses, you got GPS, and the sensor that I have there has 2 of each, so it kind of averages out and kind of does error correction right there. So the data I have, you could just work with the path planning and important information you need to know about the actual lawn and driving this vehicle around. At the top, what I haven't put yet is a LiDAR that's going to go on the top. It's this little guy here. So this LiDAR spins about like 60 RPM, and it's supposed to go on the top there, so it could keep a 2D scan of what's up front of it. It's also going to have one of these little cameras in here. This is going to be my fallback visual processing of images gathered to find out if there are any obstacles, and then use further sensor data to determine if it's actually a threat or not to the vehicle. This here is my ground control station. It doesn't do much except illustrate the sensor data that's coming through. I just had it up so we could see what's going on, but this is not the important part of this whole thing. This is just visualizing the data that you get, and I'm running ROS with various nodes published, and communication between the 2 Raspberry Pis. One of them does intensive visual processing and LiDAR processing, and the other one does all the other sensor data like GPS, IMUs, compass, and so on. So I'm going to do a quick demo here. So I've picked this guy up here, and you can see that it's the ground control station is changing, and I'm actually shifting the box around. So you can see that I'm moving things around, and you can see the attitude indicator is changing pitch roll, and it's just a flight display status of all the sensor data, so it's really good to have. And it also, I mean, this is geared towards like quadcopters, and so such as the horizon indicators in the middle. It also has like approach angles and so on. We don't probably need that for a lawn mower, but this kind of sensor data is what I'm going to use to drive the differential drive in the back. So for example, let's say my angle is inclined like this, which means my lawnmower is on a hill, then I need to know to power the right side wheel so it can keep a straight line on the hill, and so on. And then this little dot here is a compass. So as I rotate my box, you can see that it's switching directions. So it has compass data, GPS data, and lots of other information like heading, speed, blah blah blah, all this stuff. This is just a visualization of the raw amounts of data coming through. Obviously, this is not going to be run when the lawnmower is active because there's no need for a ground control station. The whole thing's supposed to be autonomous anyway, so all the decision making will happen within the Raspberry Pis, and not necessarily be piped out to my laptop here. So this is where we are. I've got lots of nodes published. Having a heck of a time with threading on the preempt kernel. I don't know, somehow the threads on a preempt kernel act differently. It kind of literally locks up the system, so not even networking works unless you're really, really careful about where the interrupts are and so on. So this is my little setup, and I've got everything hooked up, and we can actually see the sensor data coming through. So stay posted.